senior data scientist at Mars, and I also lead the engineering team at Mars right now. So rather than taking here and there, I'm just going to into the content first. So basically, I'm going to start with the basics like data wrangling. Then I'm going to give you the brief introduction about the quantitative and qualitative data variables, and then what we face as a barriers in day-to-day data modeling, and what we do as effective analysis out of the data we have with us. And then I'm going to tell you about how you can prepare at your institute, at home, and in lockdown as well. So there are a bunch of free software for data analysts, and then I'm going to show you how we do a day-to-day activities with the data, and anyone with the data, like how to choose the model and all. But I'm not going to give you every model, how to choose every model, but I'm going to give you the points, how I'm working and which model I'm working on in day-to-day life. And then I'm going to analyze the results and with the quantitative data I have got. I'm not going to show you my work, and I'm not going to share my data at all, but I'm going to take the RStudio dataset, which is already there in the R, so you can also play with that whenever you get the time. So I'll give you both the theoretical aspects in the beginning, and then I'll just jump into the RStudio and will showcase you like how I can analyze the data and how you can analyze the data, rather I should say. And then I'll just give you like brief things like how international data analysis contests are there you can participate in, and then you can also win prizes in like $1,000, $10,000, $15,000 if you win that. So if I go to the data wrangling part, basically in layman term or in the straightforward term, we can say it's the part which is, people used to talk in day-to-day life, it's the data cleaning. So if you have a big enough team in any industry like Amazon or Microsoft or maybe Google or any category where you have the big size of the team, so you have the different team sizes and different allocation for different portions of the data. So first team, when you get the data from the customer, so it directly goes to the data, like the customer success manager, and it has one-to-one meeting with how the data is moving, the data definitions and all. So I'm not going to cover those many parts, just I'm going to cover the technical aspects of it. So data wrangling is basically the process of data cleaning. And just stop me anywhere when you feel like I'm going fast. So don't hesitate to stop me anywhere wherever you feel like it's a little doubt or something like that. So data wrangling basically is the process of data cleaning. So data cleaning means it's like when you get like bunch of data, like it's in, sometimes it's so big you can't even, when you look at it, so you see like I can't understand it. So that's it. It happens to everyone in the beginning. So once you jump into the data, then you came to know like, okay, these are the definitions and these are the few variables I'm gonna play with in like for next couple of months or maybe for a couple of weeks. So you just give the little time to understand the data first of all, and then you see like you check what are the missing values, what is the size of the data, and it's not all the time true that every missing value you replace with the mean of that particular value of that particular column. But when it is it depends on the size of the data. Like if you have a big enough, then you can, replace, you can just delete those entries. And if the data size is not that big, then you try to, fill some gaps and you just take the mean. Sometimes you take the averages. So it depends like how data is moving around. So if you're little, you give something, I'll show you the visualization, how you have the correlation and how you have the relationship with the number of variables. So you take your time and then you understand, okay, I can miss these values or I can fit few mean values into those missing values. So it's like true in both the ways. So if data size is big, you delete those entries. If data size is not big, so you place your own theorem on your mind thoughts or on the data sets, right? Then third things comes, that is like most important in any data modeling part, that is the outliers. So outliers are the ones which has the exceptional values in the data set. So they are, easily identified out of the data, and the straightforward way you can just delete them out. And why I'm saying this, because what happens when you are playing with the data and you allow outliers to go into the modeling pass, then the outcomes of the model is going to be biased. So outliers plays here, right? They are the they give the side effects of the model, so people tend to avoid these outliers. So I give you an example of outliers, like if you have got the data which is related to the sales, and in any of the rows you get like the average sale you got like $10,000 a month or something like that, and whereas you find a one value which is like $1,000,000 in a month, so you can easily avoid that entry, because in a single entry you won't affect the modeling. So it's just like you don't need to get the biased result, so better to just switch off the outliers and then go forward to your data modeling part. So people used to talk about the data modeling not from now. It's like historically, if you talk about the data science, it started with the data engineering and data analytics part, which was running with the Excel sheets and all from the like 2-3 decades, but nobody was talking about pure data scientist or pure data science roles and all. But these days it's big because data is moving around industry very fast. So you have the handheld devices and all, so you have like bunch of data around you. So straightforward, as a computer science guy or like as an engineering background, you see like data as a numeric data all the time. But what happens these days, you have the devices where you put on so many things and you feel like it may be the correct categorical variable, sometimes numerical variable. So in data analytics, or you can say in data science, we say it like quantitative variable or qualitative variable. So it's simple in a straightforward way. You can say if data is numeric, so you in numerical values, then you say quantitative. If there are character values in it, then you can say qualitative. So quantitative versus quantitative, it is like all around when you start building something. So first thing comes into mind that you need to make sure that which type of data you're going to play with. And why I'm saying so, because on the basis of these particular variable shortlisting, you need to identify the model, because every model can't fit in every scenario. So that is the most important part. So there are fixed models which plays around the quantitative variables, and there are certain models which plays around the qualitative variable. So you need to be very focused, like what kind of problem you're solving and what kind of data structure you're using. So like being said this, so you need to find out like the problem statement first of all, and then you need to move forward. So basically the quantitative data measurement of the values and count and express as a number. So I can give you the points how you can identify these things. So when in a problem statement, you go with the how many, how much, how often. So these are the type of things you talk about in terms of the quantitative data. So these things moves around the numerical values all the time. So like I can give you the example, the best example for quantitative data analysis, the sales example, which I see it every day in my work. So sales data is like every time somebody is going to come to you, so they're going to ask you how much sale you had in the last quarter, and then what is the prediction for next quarter, how you can predict for the next 2 quarters of the sale. And then so like these are the things you handle, like these are the key terms you can say in quantitative data analysis, so you quantitative data modeling part. Now second thing is the qualitative. So these are the types of the character things. So if I can give you the example of which is true in both the cases, quantitative versus qualitative, but it's still a straightforward example. When you give the feedback, so you write something, you don't give the numbers. Sometimes you give the numbers, so it directly comes into the quantitative. Whereas if you are not allowed to give the numbers, and you need to write something into the blog, then it means you are going to handle the character string or something like that, and then you comes into the qualitative analysis. So these are the basic differences between these two things. So once you jump into the data science or data analytics, then you easily understand what are the numbers you are playing with, what are the strings you are playing with. So you can easily understand which kind of model you are leading with. And then after having some understanding over the data structures, I should add a couple of things here. So being a modeler, or I should say being a being into the modeling assignments, you need to have few basic things from the computer science background, like data structures, algorithm, and knowledge of any computing language. I'm not specifying any particular language here, but you should know the basic data structure of any programming language. Any programming language means I mean it, this statement, because you need to understand how the language is moving and how the data science is moving. So if you don't understand the language and you know the concept of data science, then also there is a gap. So you need to make a bridge in between these two. So you must know about the data structures and data, and how the language is moving, how the compiler works, how the when you declare something in language, how it works, and how you want to make assumptions in your way in your modeling part. So these are the few barriers in day-to-day life when you just go for modeling assignments. So these are the things you need to take care of before jumping into the hardcore of data scientist role. So if your data size is very small, so that is the toughest portion. You can't do it. You can't handle it directly because nobody is going to give you the more data, and you can add into that. Because real data sometimes comes in very sometimes it comes in chunks, sometimes it comes like very big. So these days people say like big data, but I'm not jumping into the big data right now, but I'm going to give you the clear picture that most of the time you end up with the small data size and you need to handle it. So if data size is very small, there is a formula. You need to find out that if that equation satisfies, then only you can move. You can move with the modeling part, otherwise not. So, and if the data size is small and then it is incomplete, then you can't make a model. Even if you make a model with your own, then also it's gonna fail at some moment. So I will show you how it happens and how the values you need to take care about it. And the next portion is the correlation, and you can I take it as a correlation, but you can, if you don't know about the correlation, I can tell you, you can talk about the relationships. If you know the basics of the SQL, if you know the basic or not, if you don't know the SQL, if you know the database management system, then also, and even if you don't know the database management system, then I can tell you the relationships between the variables. And I can tell you, like, if there is a schema of the data set, you must understand the relationship between those particular variables. Like I can give an example. If there is a sale, like I take example from US, there is a Walmart. So if you go to the Walmart, so there is like data, there is like everything you can find in the Walmart. So if there is a sales data, so they end up every week. So they give the values at weekend. So sometimes it runs from Monday to Sunday, sometimes it runs from Saturday to Saturday, or sometimes it runs from Sunday to Sunday. It depends on the chain. So sometimes like Costco is here, so they call it like Sunday to Sunday. Target is there, they call it like Monday to Sunday. So it's like weekly sale. So in correlation, you need to find out so if data is given into start date and end date, then you need to find out, you need to convert those start date and end date into the weekly terms, because you know the data is ending up with the weekly sale. So rather than playing with the start date, end date all the time, because it may be crucial, it may be very complex in the later stage while subtracting end date, start date, and all time and all. So you can initially, while cleaning up the data, you can convert those things into the week. So you can put it like week 1 sale, week 2 sale, or something. Like you can give the numerical value as like it's on you. You are the driver of this particular assignment. So you need to tell yourself that what kind of variable you can easily understand out of the data and how you can convert them into your understanding. It's not all the time that there is obviously there is an industry standard in it, but still making sure that you know the data better than others, because you are the whole person for playing around with the data modeling and all. If you don't understand the data, then you can't make a good model. That is for sure. Then comes the pictures. So outlier, I have already talked about the outliers. Then comes the big picture, that is the dependent variable and independent variables. So when we say like these two types of variables, we talk in data science a lot in everyday work. Dependent variable is the one which we are going to predict. in a straightforward way. Or you can say is the variable which derived you towards the end, or which derived you towards the prediction, which always pushes you towards the prediction. That is the dependent variable. And the variables which altogether make that dependent variable feasible, that is called independent variables. So I can give you an example like sale. So if I give you a number, simple number, that weekly sale is $1 million. So $1 million is the dependent variable. I can put it as a sale. So sale is the dependent variable. Now I can give you so in $1 million sale, there are say thousands of product. And there are thousands of promotions. So product versus promotions, we all together we're gonna make an equation, and that equation involves number of variables of promotions, then product versus time, everything. Then those variables is called independent variables. So independent variables gives you you need to make an independent variables combination which leads to the dependent variable. So straightforward, dependent versus independent variables are, you predict the dependent variables, whereas independent variables brings up an equation which you need to solve, and that is called as a model. Now, before jumping to any model, you should also understand that because of the big data or because of the data in front of you, you can't understand data easily. So in that particular role, data visualization brings you so much ease into the data. So if you don't know about the data visualization before jumping into the modeling, then also it's not good. So before jumping towards the modeling, you need to understand how the data visualization works. So I'm not going to give you the tough examples here. So you can start with the Excel sheet. You can take a data from, data is all around on the web. So you can download any data from Kaggle or somewhere. And then you can start playing with the Excel sheets. You can start with the pivot tables. You can go with the basics of R. You can go with the Python. You can even start with the Java. But the crux point is the conclusion of this statement is these statements are basically you need to understand when data is moving around, rather than seeing a number every time, you just put those numbers into the graph, because graph tells you more faster way rather than reading line by line. So data visualization, I always feel like you should learn data visualization before jumping into the data science. It makes you easy and it saves you a lot of time. And from the data visualization, from the graphs, you can make the relationships easily. Like I can give you an example. If you're just having one sale and you have one promotion, and in all the graph you see that one promotion is leading the sale all the time. So you can easily you can easily conclude that this is the promotion which is leading sales all the time. And then you can jump into the data set again, and then see which is that particular column and what is the missing value, what is the relationship among others and all. So this is how I can say you need to put correlation, and there are a bunch of libraries out there. You can use any library. In a single line, you put the correlation on the graphs, and you can easily understand what and how the relationships are moving into the data. So this is you can find out the hidden patterns of the data, and then you can also easily depict the relationships among those variables, which you never heard about it. So that is the beauty of data visualization. And few people talk about why to learn the data visualization. You are being data scientist. So if you want to save your time, if you want to make somebody else to understand what is going on inside your data, then this is the only tool you can talk about. Otherwise, making other, to make sense from the data, it's really tough to make non-technical or maybe some other person to make understand how the things are moving around. So this is a good thing. You should understand the data visualization. And when I say data visualization, so you have bunch of free software around you. So I use these many things. So I just wrote these many items, but if you find on Google, you can find more than this. So I use R everyday work, and then I use SQL a lot. I use IDE, RStudio, sometimes also I use the Eclipse, but not now. Jupyter Notebook, I used it it's been a while, but I am not using right now. But R and Python have many packages, many libraries for modeling purpose and for visualization, no doubt about it. You can ask from anyone. So anything till now, if you want to ask me, like if you don't understand anything, I'll be happy to help you. Otherwise, I'll move on the what I do in day-to-day life.
Yeah, Vivek sir, we have few questions, but I guess they can be answered at the Q&A part, not related to
Okay,
the session we had till now. Yeah.
sounds good. Okay. Okay. So in analytical, or you can say in data science, there are lots of models. Like there are so many models, and I don't use all the models. And even if you ask somebody, no one is using all the models all the time. It depends which problem you are solving in, and it also depends like you where you want to put your expertise. So sometimes like if you are in promotions like email promotions and all in healthcare systems, so they use like decision trees and all. So I never worked on those models and all. Since the data, I have learned the data science and I'm working on models. So since then I'm working on the sales, and in sales, the quantitative variables, I'm using regression all the time. And these days, regression has a new name. I will come to that point. I'll tell you that point also, that how the name has changed and why the people are talking about that name every day. So basically, regression has so many variant in it. So I'm going to start with the simple linear regression. Everybody knows about it, but as a technical terms, nobody use in day-to-day life, but everybody knows it because since the class 10th, all of us know about this simple linear equation y is equal to mx plus c. That particular line equation is called as a linear regression model. So we say like, if you know the definition of the line y is equal to mx plus c, so I say like c is the intercept and m is a slope and x is a variable. So y and x is the x and y coordinate. So I'm not able to draw a picture here, but you can make a picture because it's very clear to everyone. So it's a simple equation. So what does it mean as an equation here? So what we do, we have the bunch of data and we plot them on the data side, on the visualization, and then we find out some pattern in it, and then we put a line over that pattern, and we see like if our line is fitting in those patterns, it means we are good to go. If that line is not fixing, if we are not able to fix that line properly, it means we are failing somewhere, and that is not a good model. I'll show you if you want, I can show you in the R, but I'll take the R session just after finishing a few concept more, right? So this is a simple linear regression model. So if you see this particular slide, in this slide, there is a y is equal to v0 plus v1 dot x. So I say v0 as a intercept, and when you put x is equal to 0, so you feel like y is equal to b0. So you get the value of b0. And similarly, if you get the b0, then you can have the v1 and x. This is the simple equation. But the question comes how we get the values of b0 and b1 when we are modeling it. So there is there are certain rules in it. So you need to follow certain steps in it, and then you find the intercepts and other values. And if you find other values are good, then only you put those intercepts into this equation, and then you plot a line over the data or over the visualization. You can say data visualization. And before moving towards the end of the finalizing any particular model, you need to make the benchmark. You need to fulfill the benchmark standards. You need to, what I mean to say about it, like you need to make the performance better. You need to compare the performance of this model from the earlier data set or from the earlier results, and then only you can move forward that this is the final model and you can apply into the production. So there are two stages before the things move into the production. So when I say the production, it means the end product, what you use over the website or whatever you use at the end result. So it's not like you maintaining a single model. You deploy it somewhere in the web servers and then it runs overall over the data all the time and you get the outputs. It's not like that. You make so many models, you make 2 or 3 models, you tweak these models over the local machine, and then you check with the data and how your performance is moving around with the models, different models, and then you compare all these models. And with your experience, you check all other variables also, and then you choose out of those models which model you are going to deploy. So once you make the final decision, and then you make the model to go into the deployment, and there are different processes to deployment, and then you move forward. So jumping back to the simple linear regression, it's a simple line. So if you have the simple variable to predict, and there is a single variable which leads to that variable to predict, it means you have one-to-one relationship. One is independent variable, one is dependent variable. So it's a simple equation that you are depending over the x. It means there is a single variable, single dependent variable, single independent. So it's a simple linear regression. But both should be quantitative. If one of them is not quantitative, it means you're wrong. You can't use the regression model here. So in this particular regression model, you need to play with the quantitative data. Otherwise, you can't have it in your modeling. Now, once the independent variables more than one, so what do you do? Because simple linear regression model says that y is equal to mx plus c. So this is, you can't put more x into x, more independent variable into x, like x1, x2, x3, x4, x5. So in that case, you change your model and you say, I am going to use the multivariate linear regression model, and the equation remains same. You put the summation over it, and then it just move around like this. So from the single variable, from the simple linear regression model, you change only the in so many independent variables. You are adding independent variables, because in real life you never gonna have the single variable and single outcome, because in a real life situation you have so many variables into it, and you need to find out which are those important variables which are leading your sales or which are leading something else, how much and how many or something like that. And then you need to find out those x1, x2, x3 and so on, and then you need to put into the regression model. So simple linear regression model is just the theoretical aspect, because you need to start from the basics. So this is the one thing you can start with, and then you can move to multivariate. So simple linear regression is the between one independent, one dependent variables, straightforward, very easy, anyone can understand. Now, when things come up little tricky, little complex, it comes into the more than one independent variables. Now the things come now when you have more than one independent variable, then equation changes like this. So you have the same y is equal to mx plus c. So you see equation here. So I say yt is equal to beta naught and then summation of beta I into xit. Plus I am adding one more thing here, that is the epsilon t. So when you start building a model, you always have the error. So error, you can't ignore the errors, because you are not going to make a very ideal model. Whenever you write a code or whenever do something in computer science, you always prone to errors. So you need to take care about the exceptions when you write a Java code. Similarly, when you are going for the modeling purpose, you need to take care about the errors. So errors are like things you need to maintain. But in data science, what you do, you need to make the assumption first, and then you have to minimize those particular errors. So minimizing the errors is also one of the tasks into the modeling, which people used to never talk about it. And in a schooling part, when you into the class, and also in class, most of the time it ends up with this simple linear regression model and then this equation. And nobody tells you about like how the x is moving, how the errors you are going to minimize it, and how so many things are going into the modeling. So in an easy way, you can easily understand that y depends on beta naught, beta 1 x1, b2 x2 and so on. And then in the last, you just add the error portion. This is the simple equation. So this is how this comes. Now, when it comes to the multiple regression, multiple variables, or you can say multiple independent variables, then people talked about so much in terms of this, and they convert this particular big lengthy name into the mixed marketing model. So when I say mixed marketing model, so I will show you the picture first, and then I'll jump into the equation. So these days, sales not only depends on your pocket, how you buy, like how do you prefer to buy, and how much you earn, what is your family size, in which country you live in, what is the season around you, when you are going out, when you are not going out. So it's all dependent. Like these all are independent variables, and they have nothing related to each other. So it may be sometimes you get the bonus and you don't, you never think of the shopping, but you get extra money, you go for the shopping. So these are the things you can't predict. Whereas as a standard format, if you're talking about the sales in big picture, so you can have these many variables, which are, industries are, okay with this particular model. Like, okay, there is a mixed marketing model. We should follow these concepts. And these are the few factors we should take care about it. So we have distribution of the things. We have distribution like the family size, family income. And so because these are the two like biggest variables, how much you earn and what is the size, where do you live. So these three things tells you what kind of person you are these days. And if you are on social media like Facebook or something, so you are open to all. So no, so that's why the data fighting is so much there. So if you know about the geo thing today, so you can see like how the data is sailing around and how much money it has in it. So this is a simple picture. So the big picture of data is like you have so much of data around you, and with that data you don't know like how many people are thinking about it, how many people are working on it, and how they push you to buy something, and you never understand that. This is true in real picture. So we have the seasonality, we have the price, we have the promotions, we have sponsorships, we have TV ad, radio ad, YouTube ad, Facebook ad, everything is there. So you have the social media, you have digital media, you have macroeconomics factors, you have distribution. These are the few factors I am telling you. This is the standard picture you can find very easily on Google. Everybody talks about it when they call it like marketing mix model, but there are so many tweaks into it. So you can't have like X1 as a social media, X2 as a distribution, X3 as a seasonality, X3 as a price, and you can find out the intercept or the constant into it and then multiply and add them up and put into the linear regression. It's not like that. It's not that easy. You need to understand how the distribution is going on, how the seasonality put the effects into it, how the price are moving. And most important part out of this picture is the promotions. The promotions are the one which you need to talk about, which we call it in day-to-day life are the tactics or the strategies to lead. We use the term path to purchase, P2P. So that is the technical term P2P, which, everyone talk about in sales, like how you are making a customer to come to the store and buy something. That is how much aggressive you are into the advertising. So that is how we play. So this is my day-to-day task. Like I need to focus on the client's data, and then out of the client data, we need to tell them like which strategies were working on the past and which you should focus in the present and the future. So we take care of the data. Like if I'm going to take like the example of, let's say I'll take the Indian example. Let's say Lay's. Lay's has so many, chips around you. Lay's has so many products, or Pepsi or Coke, whatever. You can take one example. So Lay's is the one example where you have so many products. So if Lay's ask us to promote their product in different stores, so what I'm going to do, so what Mars is going to do, we are going to ask them that, okay, we are going to work for you, and you just tell us like what is your budget for the advertising and what was your sale up until now, and then you just tell us like how much prediction, how much duration you want to predict your sales, or how much promotions you want from us. So we charge for it, we charge for their predictions. They give us like their budget size. So they say like we are going to spend $10 million the next year for these products, and these are the stores we tie up with. So they say, okay, we have the Walmart, we have the Costco, we have the Target. So every store has a bunch of Lay's product, and so you tell us like at which store we should follow which tactic to make the sales better. So this is our task. This is the data scientist role. So what I do, I just simply go into the data. I just check like the weekly sales is given to me since last. So I'm not going to talk about like 10 years of sale, because if you are going to jump into 10 years of sale or 20 years of sales, you are never going to predict anything, because the data size will be so huge. You're going to jump into it and you will take years to predict, because you will finalize something that will be fail into the some years, and when you are going to finalize 2014-15, it's gonna fail in 16-17. So what we do in present scenario, we take the last 3 years sales or last 4 years sales as max, because the sales is so huge, data size is so huge, that in 4 or 5 years you get to know everything around it. Which product is booming, which product is not booming, which product has which values, or something like that. So what we call it as a marketing mix model. So marketing mix model is not simple like the multivariant variable, like you need to put x1, x2 and all, and then you put the error and then intercept. It's not that way. What we do here, we say like, okay, we have a bunch of independent variables. So we put into the beta1 xt, and then we have the error rate. Now, this x1t is also dependent on some other variables. So that is we need to talk about. That is how the marketing mix model works in the real picture. So it's not like it's look like the simple explain that, okay, t is the time, explain, and these are the few constant here. So at some given time, you measure xt, you measure beta1, you measure error rate and something like that. But basically, beside these particular variables, you need to focus on these 4 parameters. So these are called carryover effects. So basically, why I'm discussing this, because as a student, you should know like how to hit a model in the real picture, because I was failing once I started my job because of these few things, because nobody has told me in my class. They have told all the Bayesian model, decision tree, everything. They asked me to code every model on the given data set. But in a real situation, these are different things. You need to take so many things into the model, and they never come up in the class. So that is the most crucial part. And you take a lot of time to understand these things into the industry, because they are moving so fast and you need to deliver in the time. So that is the one thing you need to take care. So better you get time in the college, in the school, and you spend some time if you wish to become a data scientist. So you just choose the field, because the sales is the field which never gonna down. So you can learn one model or 2 models, and you make the expertise on those particular models and solve. I feel like solve 5 to 6 problems. It means like 5 to 6 projects. Put them into resume, put them on LinkedIn, put them in data visualization form, put into the web link, and just do like that. So it helps you to grow in the field of data science, and you learn more about it. So once you're hands-on on those particular projects. So these are like so come back to this point. So these are the several key factors which you need to talk about in terms of the marketing mix model. So this is one. So I'm going to read it line by line, because they make sense into the modeling part. So you need to expose it to the advertising. So I give example, advertising doesn't mean that you show advertise today and you're going to get the results today at the end of the day. No, it never happens like that. So advertising is one thing you have flush it out today, and you're going to have those particular things in the later future. So that is why we say it as a carryover effect. So every advertise has the carryover effect. So if you have, like I give you example, if you watch YouTube at 18 plus age, and you watch YouTube at 6 plus age, you watch YouTube kid, you watch YouTube as a like adult. So you have like different bunch of advertisement. So if you see the cartoon, you have the advertisement of the kids, like kids product, and that is the best effective way for carryover effect. So in your home, like your nephew, your niece or whatever, whoever is watching the YouTube kid or maybe the Cartoon Network or whatever, now the advertise comes into the picture. And that advertise belongs to those products which child every day in their day-to-day life they use it, like bicycle. So if your kid is of age 6 or 7, so the bike ad comes into the picture, and they like the football ad or something like that. So when they go into the market, they ask the same thing. That is the carryover effect. So you need to focus on those effects, and then you need to incorporate those effects into your marketing model, and then you can say my model is good. Otherwise, simple linear regression won't affect much. Then you have the effect of ad exposure, like which is leading to your purchasing decision, which is the part to purchase. What is the factor to part to purchase? It's not all the time you see the advertisement and you go to the shop and you buy it. No. So you see the advertisement, somebody follows up, like There is a silent follower, there is a calling up. So like in day-to-day advertisement, nobody is going to call you that, okay, XYZ, just taste this particular chips or you just buy this bike and all. No, they never follow like that. So if they show you advertisement, and then what happens, they give you they have your data, how you move around, what you like on Facebook, what you do around your network, and what you do on laptop, and so you have single ID and you click everywhere. So clicking data is more important. So these are the carryover effect. So you like bike, you like some pages where you see those particular bikes and all. So what they do, your phone number is associated with your ID. So they're gonna send you some messages. They're gonna send you emails, and it's not like one time. They're gonna send you repeatedly, and it's like they don't bother. Like they don't mind it to send you to make you bother. So you feel irritated, but they never feel irritated. They just send you every time. They feel like if somebody is clicking that particular email and going to ask the prices and everything, they put a query against it, then you have a certain follow-up. And then they say, okay, we have converted this particular customer into the sale path to purchase. And then they choose like, okay, email was the effective factor while this customer was coming, because they put the code in it. So you choose SMS, so there is a different character code. If you choose email, there is a different character code. So they know that which code you are using, from which platform you are coming and asking for that product and purchasing that product. So this is called tactic. So I play every day. Like I have a bunch of tactics. I don't remember the name, but I have got 70 tactics. So 70 tactics has their weight is, and they have certain, you need to focus on the values also. Which tactics plays, like which tactic cost how much to you. So like I can tell you, for the email for 1,000 people, so for us 1,000 reaches $3. So $3 we spend, and then we send an email to 1,000 people. So I'm telling you the like a rough idea, but $3 is so much. It's like 30 cents or something. So these are the carryover effect. Never mind it. Okay. And then it comes to the shape effect. And the shape effect is the one thing. It's not all the time you put the advertise into the picture and your sales is going to boost. Sometimes you have the diminishing return point. So that is called the S curve. So S curve means if you know about logarithmic curves and all, like e to the power x, y is equal to e to the power x curve or something like. So if you know that curve, so it moves around S shape, and I'm not going to talk about the bottom part of the S shape. I'm going to talk about the upper part of the S shape. So at certain point of X value, there is a Y which moves into the straight line. It means at certain points, your return is not going to increase. That is a diminishing point. So it means you need to, prior to modeling, you need to calculate that point where your sales is going to achieve at the high point. And then later on, you put as many ads, it never going to affect your sales. That is also true. So it's not always true that you put more money into the advertisement, your sales is going to up. So you need to take care about the diminishing point. So these are the factors you need to focus before jumping into the modeling or anything when it comes to the marketing. Now you can easily understand that what I talked in like last 10 minutes. So this is the simple equation. So I have simplest version of the model to make you understand how the things are moving in industry, how the people think when they develop the model. So you are not going to jump directly into a single model. You need to divide your at the smallest granular level. You need to divide your problem. Then from there, you need to go for bottom-up approach. You need to connect the dots. And once you are able to connect all the dots, then you say, I understand the problem. I can build a model, and then I can deploy a model. But it's like multi-phase, problem. It's not like a single one-to-one problem. You get the data and you model it. So you need to divide that problem into different phases, and then you need to achieve one phase done, second phase done, third phase done, and then you start building your model. But once you are clear, like 70% of your time is going to invest into the data understanding and data visualization, data relationships, and then you need to give 30% time in modeling. And in 30%, when I say 30%, it means I'm talking about all the performance related issues, which variable you want to put in, which variable you don't want to put in. So these testing and all, I want like this 30% includes everything. So in simple terms, I can say multivariate regression model can be used into the mixed marketing model, but not straightforward. You need to make sure that you are including the carry forward effects. You need to include the shape effect. Then only you can say that this model is going to work in real scenario. So after converting these 4 or 5 lines into the mathematical terms, I can say first line should be the simple line. So if I compare this line, so you see here xt. So yt is equal to beta naught plus beta X2 may be the income of the family. X3 may be something else. Now you can see, but S1, S2, S3, S4, they also have something ST minus 1 into delta, lambda, whatever you say. Typically, we start S0 with 0 so that we can easily input the X value or something for lambda. But the most complex part in these two equations is how to calculate the coefficient. That is the most important part. And in real scenario, in the class, nobody tells about like simple coefficient, everybody talk about like how to calculate it. I will also show you those particular value. And then for these lambda and all, nobody tells you how to calculate them. So for calculating them, you need to understand the linear equation, you need to understand the logarithmic functions. So for me, like if somebody asks me to give everything into 1 hour, that will be like not just to those particular models and all, because for understanding these two equations only, you need to take like continuously 6 hours to make so with the time constraint, I'm going to analyze the output, how you recognize the output, and then I'm going to jump over the R, and I'll give the example from cleaning to the modeling part in a big way, how to clean it and how to make a model and how to pick the outputs and what it tells when as data scientist, how you depict the output, how you confirm those output and how you gonna tell those output to your manager or maybe to your boss or somewhere else. So intercept are the basic things that everybody knows about it. Like we are using y is equal to mx plus c. So c is the first intercept you need to calculate. So basically these coefficient or all the intercepts, and I'm going to show you how to calculate these coefficient. Now p-value and r squared and adjusted r squared. These are the two common things which everybody asks in your interview. So not only from the interview side, you should know in real life also. P-value is basically the hypothesis you put on the subsets. Basically, you're not going to take all the data for data modeling purpose. You take a set of that subset of the data, and you put all the assumptions, everything on the small data set. So you need to make sure that if your model is running on the small data set, it should run over the biggest data set or the full data set. So where in that particular process, hypothesis come. So you need to say like, so there is a p-value. So p-value should be always less than 0.02. Like this is the standard. You can just research it out and you can have certain value, but this has a certain value which should be always less than 0.02. And if hypothesis is true, it means whatever you are doing on the small data set gonna be true on the bigger data set. So you need to make sure that your hypothesis is true. If it is not true, it means you are failing. You need to refocus again. You need to re-understand the problem, and then you need to restart it. Otherwise, if you ignore the p-value, what comes? You deploy the model, and later on, what happens? It fails. Whatever value you give it gives you wrong prediction, and which never accepted at all at any point of time. So that's why p-value is most important. And if you want to understand p-value, like out of this class also. So you can type into the Google what you have the significant p-values in the modeling. So they will give you the lecture on hypothesis, how you calculate the hypothesis. So you can have like 10 hours of videos and you can still don't understand the p-values. So it's like you need to give like reading a small chapter from mathematical books, that is more fruitful for you. Now, second thing comes the R squared and adjusted R squared. So many people fail on this particular line, and this is also known as like model performance. So many people ask you in interview how you measure your model performance and what is the difference between R squared and adjusted R squared. So R square is the simple thing. Everybody see it and say, okay, R square is 0.89. Okay, my model is 89%. Performance 89%. True. Then in the same line, it shows adjusted R square is 0.83. Somebody says, okay, my model performance 83%. Which one is the exact model performance? So basic difference is when you include independent variable into your model, like you included x1, x2, x3. So just listen carefully. If you include in the first thing, if you include in first model x1 plus x2 plus x3 as an independent variable, and R square is 0.89 and adjusted R square is 0.83. Now what happens? You again rewrite the problem and you say, okay, x1, x2, x3 were there, but I think x4 is also important as an independent variable to calculate the performance of the model. You include x4 as an independent variable. Now your equation changes, model goes and models again gives you the R square 0.89, but R square adjusted, it gives you 0.81. So it means when you are adding up those independent variables and your adjusted R square is going down or going up, it means that particular variable has having more impact on the data. It means you should include that variable or not. It depends on the adjusted R square. So I can make sure that you should know adjusted R square and R square, and I'll means after this class, whenever you get time, you just make sure that you know the t values, like p values, R square, adjusted R square, and one more value is t value, which I am not including here. That has some other significance. Because of the time, I'm not including that. So make sure you know these particular values clearly, and you make sure that you know the picture that how these things affect on your model. And beside this, you should also know the standard deviation, mean, max, and range, whatever things come into your data set. You should know all those variables very frequently. And then in the last, it comes when you build a model, somebody says, okay, this model is too well. It means every time it is giving you the good result. It means it is overfitted. The meaning of overfit is it when you are testing it, it means you are not having the good data or you don't have the sufficient data for testing it. So that's why your model is running at the upside. It is always giving you the good results. That is the too well. That is not acceptable. So overfit is not allowed in your model. It means somewhere you are leaking in the data. So you need to go back and then check the size of the data, and then you have to go for the size. Here the size means is test data size or the input from the user. Or when you are building a model, you divide the data into the test and you divide into data the performance. So your test data is small. Underfitted means you did not capture anything into the data well. That's why you don't do anything, and that is also not acceptable. So overfitted, underfitted, not acceptable straight away. If R square, adjusted R square is moving apart, and when you introduce a new variable, independent variable, adjusted R square goes down or goes up, then you need to focus. If it is goes down, there is no need to include it. If it is going up, then you need to rethink about your independent variables. P-value is hypothesis. Hypothesis must be true. It means in your small data set, if your model is good, it means it's going to run overall good in the big data set. And intercept, I'm going to show you how to calculate those intercept, and then let's go to the RStudio. Now, before jumping to RStudio, I want to ask you if you have any question from anywhere, you can ask me here.
Yep, Vivek sir, we have actually lots of questions, so we can means after this example we can move on to the Q&A part.
Okay, so you want me to continue on the RStudio, right?
Yeah, then I guess we can done with the Q&A part.
Okay. I was little fast because of the time, and also it's for me, it's 2 a.m. So I am moving little fast. So I'll give you one example, good example. So here I'm using a simple data set which is available in your RStudio. What I'm using, it's a RStudio, I can show you. So in my Mac machine, I have the RStudio here. So for RStudio, you need to download the R from the current projects and then latest version with the, and this is the type of ID. So if you know Eclipse, so it is similar to Eclipse. So RStudio is there. And I'm using the internet data set. So with the all the libraries are there, so I'm already done with all libraries around. So I'm just loading the data set. So this is your editor, this is your environment. So the beauty of this editor is whenever you have anything, it comes into the environment. This is the local file, so you just go and this is your system or from where you are running. And this, you need not to go with the setting libraries and all from the manual. You can just directly go in and set as a working directory from where you want to run the project. Then you can just see the what is the head. So I'm taking the data set which is from the R. So it has the flower database and which has the length of the sepal, the width of the and the petal, and then it goes that which type of flower it is. So this is the sort of prediction from the length and width. This is the numerical data set, and this is the species you need to talk about or you need to predict. So this is simple, very simple. And I'm going to show you like how you can make a web application in the R. It's very straightforward, simple. So before jumping to the modeling part, I'm just going to plot the data set. So this is, I have just used the plot function and scattered plot, and I see. So when you plot the function, so I took the petal length and petal width. So I see there is a graph, and these are the values which are moving into this in XY plane. So I see, okay, there are a bunch of values. I can put a simple line here, and that may be my model. This is kind of thing. So I just put the model. That is LM is the linear model. This is simple linear regression model. What you do here, you just have the y, this is y, tilted sign, and whatever x. So y and x. So this is the dependent variable, and this is the independent variable. If you have another independent variable, you just put the plus sign here, and you can add so many variables. Simple. So I have done with the model. Now I just put the summary. So when I come with the summary, so in summary, you just go into the terminal side and you see these are the things I have got. So many things. And these are the things I was talking about in terms of p values, the coefficients and the standard, the R square, adjusted R square. Everything is here. If you see this picture, the bottom one, the selected one, you see everything is there, which I have talked about in my last slide. So intercept is like, this is the value, this is the intercept. It means when nothing was there, so intercept is 0.36, which has the negative correlation. And then petal length has the plus positive correlation, which has some values, 0.45. So now you can build the equation y is equal to mx plus c. You have got the intercept m, you have got the x, because I have got two variables. So this is simple linear equation. Then I said about the t value. So t value must be less than 2 or equal to 2. That is different case. So I'm not going to touch the t value here. I'm going to touch the p value. And so the p value is also less than 2 points. So it's 0.002. So it's sufficient. It means the hypothesis we made is true, which is good. And then we have multiple, so we have R squared 0.92, we have adjusted R squared 0.92. So it means both are good, both are same, because we have single variables, so we can't compare these two things, but you should know what is the difference between R squared and adjusted R squared. Now our task is to make a line which can show us like how much we have covered. So our model is going to cover this line. So the error rate is if you see the bubbles, so the distance from bubble to that particular red line is called the error. So when you say like, I need to increase the performance of my model, it means you're talking about to minimize those particular dependent, like the perpendicular lines from those bubble to the line. So that is the error rate. So when you decrease those particular gaps from bubbles to that red line, it means you are minimizing those error. So, or it has two meanings. Either you rotate your line slightly up and down, so there's that also possible, or that is the only thing like you can do. So you need to tilt your red line little low or little up. So that is how you make the model performance up and down. Then you are having correlation. So this is how I made the simple correlation coefficient between the length, petal length, and between the width. And after this, I can give you the predict. So when you predict, you can just put the new values into it and it will predict for you. So it will predict the length of the value. So these are the answer. So if I go directly to I just made a simple web application. So before that, I need to run this one because I need to have some few variables here and there. So I can show you how just, so this is the simple, so you can make a simple web application which runs over like the Eclipse localhost and all. So this is also 𝗏𝗨𝗍𝗍 is the web. So this is a simple application. We are predicting these spaces. We have the 5 things and we have just length and all. So you can just put the length into it and you can say the X. So this is the prediction. So if you increase it, so it goes here. So this is how you are predicting. So you give the petal length and you give the petal width, and this is how you move with the values. So this is the simple example. And if you wish, I can go through with this code once. So if you have any doubt on, I can't show you the marketing mix model from my code, but I can clear doubts if you wish. And yeah, I want to show you one more thing, like how you start with the data. Okay. And this is again one other data set, which is also from the RStudio. So this is the simple car data. I am having the car data set, and then I am just making the simple graphs in it. So I said, like, before jumping into the modeling, you should understand how the visualization comes into the picture. So this is the data set from the car. I can show you. So these have these variables. So they have given us transmission, they have given us cylinders and the fuel economy. So we have just built a small graph where you have the count of the cars, like which car it has, and then is it automatic or is it manual, which side it comes. So we have more automatic cars rather than manual. This is also one relation you found from this. Again, you can put the histogram. So in histogram, you count the frequency. So you can easily depict which car has which number of frequency. This is the distribution of fuel economy. So this is how you can put different graphs. This is a scatter plot. So you can have the number of cylinders for each and every fuel economy. So this is how you start with the data visualization, and then you go with the modeling part. And before moving towards the graphs, you should also know what is the min value, what is the max value, what is the mean, median, quantile, and then standard deviation. So these are the basic mathematical terms you should know before moving towards the modeling part, because these are the things you need to hit every day. Because sometimes what happens, some missing values are there. Everything is given, but 2 or 3 missing values are not there into your sales data or somewhere. And the rows are not, you can't delete those rows because everything else is all there in place. So what you do, you need to check for that particular variable, what is the standard deviation, what is the mean, how much you can add into it. Because if the missing values are very less, you need not to delete them. You need to calculate them. So you should know what is the mathematics around it. And R and Pythons are, such an easy language. They just give you the calculative, like they are just a calculator. So if you understand the data structure of these 2 languages or any other language which are easy for data set, you can easily go with the mathematical things in a second. So if time, like, I don't know how much time I have got. So, but if this lecture can be extended, or I can have the multiple lectures. So I usually, even in my office, if somebody asks me to train the newcomers or the interns, so I give the basics of language first of all, and I give the small examples of for loop and all. and then jump into the like how you read the array, how you convert the strings, how you play around with the numbers. So these are the few things you should understand before jumping into the modeling part.